These are the answers to the final set of exam questions you need to try before the maths exam on Monday, May the 11th. In the first question to do with cricket scores, you're going to be asked to work out an estimate of the mean. To do this, you'll have some blank columns on your table in the exam. The first one needs to be filled with the midpoint. That's these values, that's the middle of each group. The middle of 0 is still 0. The middle of 1 to 20 is 10.5. 21 to 40 is 30.5. Some of you need to pay attention to these midpoints. They're not easy to get yourself. This column is filled in by doing the midpoint times the frequency. So frequency number times the midpoint gives these numbers over here. They then need to be added together to get a total. The frequency numbers need a total, which should be 72. And then you divide this total by this answer, this total over here, to give a final answer for an estimate of the mean, which has been rounded to 1 decimal place. The modal class is the most common result. If you look at the frequency numbers, the biggest is 21, and that represents the group 1 to 20. So 1 to 20 is the most common result. Range is highest, take away lowest, and in this sentence here, you are told the highest score, and from the table, the lowest score is 137. The median, you'd probably just have to remember. They may ask you to compare this against another cricketer. So here I've made up some figures for another cricketer. We would first need to work out his mean, which is the number of runs divided by the number of matches, given an average of 23. The range, again, is the highest, take away the lowest, and that gives 90. And you can see the first cricketer, Alistair Cook, had a much greater mean. So you'd write a sentence like this: the mean for Alistair Cook is greater than the mean for Michael Vaughan. The range for Alistair Cook is greater than the range for Michael Vaughan. So you're comparing the two means against each other. You're comparing the two ranges against each other. In this question over here, you need to understand how to use this formula, which calculates how easy a piece of text is to read, ranging it from very easy to very confusing. The formula will be given to you in the exam, which is this one here. So, I've got two examples over here. The first one is a history paragraph, which had 5 sentences. In those 5 sentences, there were 90 words and 162 syllables. So first you would have to work out the two figures in this formula that you need to know, x and y. You're told what they are over here. X is the mean number of words per sentence. So to work that out, we need to do the number of sentences, the number of words divided by the number of sentences. 18. Y is the mean number of syllables per word. So syllables divided by words. 1.8. Once you know the value of x and y, then you're going to put that information into the formula, typing it in exactly how you see the formula. And where you see the letter x, you're replacing it with the value for x. So it's 1.015 times x. Take away this number times y, whatever the y value is that you've calculated. And you get this answer on your calculator, which I'm going to round off to the nearest whole number. And if you look up 36 on this table, it would fall between 30 and 49, which is difficult. Instead, in this question, they may instead give you the x and y already calculated, so you don't have to calculate them yourselves. You would go straight to the formula, learning how to input x and y in this formula. So you type in the whole thing, the whole formula, with the x in this case replaced with the x value and the y letter replaced with that, remembering you're doing 1.015 times x, take away 84.6 times y. This is the answer. I've rounded it off to the nearest whole number, 57, and again, looking it up on the table, that would be fairly difficult. If you want further practice, go back to the questions you were given earlier last week, and there's a spreadsheet for you to fill in. In this question, you will often be asked questions to do with fractions and percentages and probability. So this is a survey showing what percentage of children did not recognise certain types of sea creatures. Let's imagine that this survey is out of 500 children. We might be asked to work out how many children did not identify an octopus. We know from the table that's 29%. So you would have to work out 29% of the survey total 500, which is this calculation. You would have to know this method to do it to get this answer. If you look at the remaining questions over here, for instance, how many children did recognise a turtle? Well, 28% didn't, so 72% did recognise a turtle. The information in the table are children who did not identify those animals. So again, you need to know how to work out 72% of 500. Here the question says, write that information as a fraction. So again, what percentage did not recognise a penguin? 18%, and a percentage is out of 100. So it's 18 out of 100. And to get full marks, you might need to be writing it in simplest form. If you've got a calculator, type that in. Using the fraction button, press equals, it will simplify the fraction for you. 9 children did not recognise a shark. Express it as a percentage. This is the formula. First write it as a fraction, 9 out of 500 times 100 to make it into a percentage. A probability is written as a fraction. So the probability that a child does not recognise a crab, 16%. 16 out of 100, and that's simplified. Another possibility for this survey is they may present you with the differences between boys and girls. So they ask both boys and girls whether they recognise these animals, and here information is presented in a dual bar chart like this. So how many girls did not recognise a clownfish? That's the first bar. There's the boys, that's easy to read. Approximately 120. Looking at the length of this bar, you're going to have to estimate against this scale. For girls, it's from there to there. So you can see what I've done. The top of the bar is 230, the bottom of the girls' bar is 120. So the gap, the difference between them, is take them away from each other, giving an answer of 110. How many more boys than girls recognised a penguin? Again, what I've done there is looked at the information for a penguin in this bar chart and worked out how many boys and girls individually did not recognise a penguin. I'm estimating these numbers. I can't read them exactly, but I'm estimating them. So that's 30 more boys than girls. Another option is to draw a scatter diagram. So here I've got a simple table, again with the number of boys and girls who did not recognise these animals. I've plotted them on a scatter diagram. Remind yourself how to do a scatter diagram and a line of best fit. To do a line of best fit, it must go through the mean point. Remember, that means you have to work out the average of the boys and girls in this case separately. Those two numbers in red I've plotted here. And the line of best fit has got to go through the middle of the group of data and through that dot, that red dot. Two possible questions for BBC spending. One is a spreadsheet. So in this spreadsheet, a variety of different options. I've not included the whole spreadsheet. I've only done certain channels here, but the same would apply for any other channel. So here we've been given the spending on 4 different channels in the BBC in 2012 and the amount they spent on those channels in 2013. To work out the change, you would look at the difference between these numbers. So you're taking them away from each other. If there's been an increase, it's a normal number, a positive number. If it's gone down in value, that's a negative number. The percentages, to work that out, the percentage change, you're doing the change divided by the first number, the one in this column, times by 100. The change divided by this times by 100. Change divided by that times by 100, I'm rounding off to 1 decimal place, or whatever they ask you to do in the exam. If the change is negative, the percentage is written as a negative as well. They could ask you to work out the percentage of the total. What that means is something simple. If you look at 2012, I could add up those numbers. So that's the total amount of money the BBC spent on all 4 channels. And we might need to work out how much they spent on the BBC One. To get this answer over here, you do the amount they spent on BBC One divided by the total times by 100. Amount divided by the total times by 100. Repeat it for BBC Two. Amount divided by the total times by 100. And that gives the percentage of the total. They might ask you to create a pie chart. If they do, they might only give you part of the channels to work on. So here, I'm going to make a pie chart of this information. I need a total for that. And then you have to work out the angles. The formula for this is amount divided by the total times 360. Amount divided by the total times 360. All of these figures are rounded off to the nearest whole degree, and they should add up to approximately, not exactly, approximately 360 degrees. And then you need to be sure you know how to actually draw the pie chart and label it. The biggest angle, which is hardest to draw, that one, I didn't actually draw. I left it. I did the other 3 angles, and the remaining one must be the hard one to draw, which is the 234 degree one. This is looking at the table for exam results and doing a histogram. So to do a histogram, we need to work out something called frequency density, which is done by doing the frequency divided by 10, the gap between each group. So the gap between the first and the last number, 206 divided by 10. This number divided by 10. This number divided by 10. This number, though, divided by 5. The gap between 30 and 35 is only 5. So you're doing this number divided by 5. Check you're getting all these frequency densities right. Then it comes to plotting the graph. Look at your biggest frequency density number. You need to go up to just under 80. And these marks will go along the bottom. So over here you can see the graph drawn. I've gone up in 10s along the bottom because that makes sense. I've got to get up to 60. And here I've gone up in 10s as well. You're going to have to estimate some of these numbers. So 20.6 is close to 21. So you can see as long as you've got it within a square, you're fine. The bar will start at the beginning of the group and end at the end of the group. So the first bar starts at 0 and finishes at 10 and goes up to the frequency density number. The second bar starts at 10, finishes at 20. This one, though, starts at 30, finishes at 35. This one starts at 35 and finishes at 40, and so on. To work out how many students score above 45 marks, you need to work out the area of these bars above 45. This same question and table of information can be done as a cumulative frequency graph as well. So here I'm reminding you about cumulative frequency. That's where you add up all of these frequency numbers, which is what we've done over here. The last number should be this total. So these numbers need to be plotted vertically and the marks will be along the bottom. That's quite easy. You'll go up in 10s to get up to 60. But if you look at this number here, this needs to go up to nearly 3,000. So, as you can see from this graph, I've gone up in 10s along the bottom and 500s vertically. That means every small square here is worth 1, but every small square here is worth 50. So, what are you plotting? You're plotting 10 against that first number. Again, you're going to have to estimate. If you look at this first number, 206, you can only plot to the nearest 50 on this graph, so 200. The closest square you will find for this number is 650, 1300, 1700, 2050, 2650, 2900. And you always plot the last number with that number. Have a look at the results again. So that produces these points which you join up with a smooth curve, making your cumulative frequency curve. Again, then you have to work out things like the median, the upper and lower quartile. So the median is going to be things like half of 2890. And again, if you do that on your calculator, you get 1445, 1450, which is just one small square below 1500. So that's where I've done the median line. Go across, go down, read what that's pointing to. Use your ruler if you're not sure. So half this number will be over here, across, lower quartile, upper quartile. Then interquartile range is the difference between the upper quartile, take away the lower quartile. And here's a sketch of the box and whisker diagram, which you'll probably be asked to draw on a separate piece of graph paper. You can draw that once you've worked out the median, the lower quartile, the upper quartile. The biggest result we know is 2890, and the smallest result is potentially 0. In this question, we are looking at a questionnaire and some of the ways in which we can ask a question and some of the ways in which a question may have problems with it. So, in the first question, write down 2 criticisms of this question. How often do you use the library? Never, sometimes, often. For responses, you shouldn't use adjectives, words, you should have numbers instead. And here, in this kind of question, you need a timescale, like per week, per month, per year. Here's a much better question. How often do you use the library per month? 0, 1 to 2, 3 to 4, 5 or more. You'll notice the numbers don't overlap. So here, if I started with 2 to 4, that would be confusing for somebody who only visited twice a month. And make sure you've got one for every category. So here I've just done 5 or more, and that includes anybody with 5 or more than 5. Here, a random sample is one which is not biased. So for instance, it would not be a good idea to get information about the library by going to the library and asking people using the library. You want to ask other people as well. A method for collecting a random sample is using an electoral register. In this question over here, you might be asked to read information from the graphs, answer questions about the graphs, and to criticize the graphs. To do that accurately, you need to know what the small squares stand for on each graph. So here I've written in red what the small squares on each graph are. So that's going up in 4s, every 2 years, 0.4. These small squares are every 5 years, every 5 years, and a 0.1. So if you were to look at general trends in the graph, you can see over here the carbon dioxide in the atmosphere is increasing, so that's CO2 is increasing. The sea ice at the Arctic is decreasing, and the land surface temperature is increasing. That's an error there. It should read increasing, obviously. Yeah, land surface temperature is increasing. Criticize the graphs. The 2 main criticisms are for each graph, the vertical axis does not start at 0 for, those 2 graphs there. So this one starts at 300, this one starts at 4, they should both start at 0. This one does have a 0, so this one is fine. And for all 3 graphs, they should be comparing the same time period. So if they'd chosen 1955 to 2015, they should have chosen the same time period to start and finish the other 2 graphs. In the final part of this question, they might ask you to read information on the graph. So as you can see over here, I've been asked to work out the change from 1955 to 1985, looking at the carbon dioxide in the atmosphere. I've read the two numbers for those 2 years, and then I'm looking at the difference between them. Again, to do that successfully, I need to understand in that graph the small squares are going up in 4s. To calculate the change as a percentage, the change divided by the original amount, which is the figure for 1955, times by 100. That's how I've worked out the percentage change. And to work out the change in land surface temperature, I've read two figures, one of which is negative. So the actual gap between minus 0.5 and 1 is a gap of 1.5. In these graphs over here, you may be asked some simple questions and some very complicated questions. You should be able to pick up the marks for the simplest ones first. Describe the overall trend of UK power generated by gas. The main thing this is showing is that the amount of gas we're using to make electricity, to generate electricity, has decreased, and the volume of coal we're using has increased. So the total amount of electricity generated by coal has increased, the amount generated by gas has decreased. What's the percentage increase in coal from the beginning of this period to the end? Well, it started at 30%, went up to 42%, so that's a gap, a difference of 12%, a 12% increase. When did coal overtake gas? That's where the two graphs cross over. You're going to have to estimate it. It looks like near the end of 2011. So I've put either of these 2 months and 2011. Then it gets extremely complicated. They might ask you to work, they might tell you how much electricity is made in the UK every year and how much of that was made by coal. That would involve working out 42% of the total. To do this on a calculator, you would do 42 divided by 100 times that number, which comes to this figure, and a similar calculation for gas. The two circles also tell you how much carbon is emitted into the atmosphere by gas and coal. So, to work this out, we would have to do the following calculation. This would be the next part of the question. So you would have already worked out how much electricity is generated by coal, for instance, and you times that by that figure if you're working it out in tonnes. And as you can see, you've got an answer over here, and there's a similar calculation for gas. This question is going to ask you how big the two circles are by comparing the two numbers. This is an extremely complicated method, and it's one which you would, if you had time, you would learn this method we've described over here, remembering the sequence of numbers you need to input onto your calculator. You can try it. It's not that likely to come up, and if it does, it will be a very complicated method.